Hi friends, and welcome back to A New Way to Museum. I'm your host for today, Curtis Schmidt, the Zoological Collections Manager. If you guys remember back a few weeks ago, we had one of these segments that focused on why we collect things and what collections managers do. So I'm going to go into detail about why we have the collections that we do. If you remember, we talked about how the bulk of the museum is basically built around the scientific research collections, which is true of even small museums and large museums. We are no different. So all the neat exhibits that we have upstairs, really neat stuff, pays the bills. But the bread and butter of the museum are the scientific research collections. So I'm going to give you some of the reasons why we have some of those collections. First and foremost, whenever I give a tour and I talk about the reasons why we have these collections, I like to talk about measuring and monitoring biological diversity. So a lot of people will look into our cabinets and look at drawers like this. And they question, why do you have so many of the same thing? Why do you need to continue to collect those things? Same thing if you look over here with the rat snakes here. Why do you collect so many? Why do you have so many? So going back to that measuring and monitoring biological diversity, you have to think about these things aren't all collected at the same place at the same time. So basically what we're doing is we're collecting things to give us a snapshot of what lives in a given place at a given time, and then the museum serves as a permanent record, or basically a library of that information, if you will. So going back to this drawer right here, sure, you see a whole lot of common buckeye butterflies, but each one of those has a tag underneath it that says when it was collected and where it was collected, and I would bet good money that no two of those tags are the same. So that's how you have to look at things collected over space and through time. So that's the measuring biological diversity, what lives in a given place at a given time. Monitoring biological diversity is how does that change through time? And my favorite example is our fish collection. So we have 2 government contracts currently to be the repository for their fish. So basically, where they keep their voucher specimens. So Wildlife and Parks goes out and does a stream survey. So they'll mark off about, say, 300 meters of a stream. They'll seine it, they'll shock it, they'll do everything they can to get a really good idea of the diversity of fishes in that stream. Now at the same time they're doing that, they're also collecting habitat data. So how wide is the stream? How deep is the stream? What is the stream flow? What is the water chemistry? What are the invertebrates that are living down underground, underneath the water column that feed that diversity of fishes? They collect all that information and then they send the voucher specimens here. So say 20 years later, 50 years later, 100 years later, they can go back to that exact same spot and do the exact same thing that they did, and then they'll have 2 sets of data. They can compare those sets of data. So they're obviously typically not going to be the same. So say the first time they go out, they catch 2,000 individuals of 20 different species. The second time they go out, they get 50 individuals of 2 species. Then they've got the data they can try and figure out why things changed in that amount of time. Because we know, we as humans, we cause lots of havoc. We cause lots of negative impacts on the environment. So we can try and figure out what might have happened in that time span to change what we're finding. To change the biological community within that stream. And the museum here is wonderful because we keep the voucher specimens. So they will take representatives of each of those species and preserve them and send them here. So we'll collect the data, where they came from, when they were collected, the species that they are. We'll make sure that they were identified properly. Then we'll store them forever. So we do that all the time. And then they can do that again, and we'll always have that information here. So I hope that makes sense with the whole measuring and monitoring biological diversity. I've been involved in lots of different surveys of, say, state parks or other federal lands, things like that, where we go out just to see what's there at that given time. And then again, we'll take representatives of each species that we find and we'll put them into the museum here. So that's probably the number one reason why we have museum collections like this, and why big museums do as well. Now there's infinite possibilities of things that you can study looking at these specimens. So even once those specimens come in from a survey, they will then be available for anyone to use for a wide variety of things, whatever a researcher wants to look at. So some of those examples, diet studies. So specimens like this right here, okay, these are stored in alcohol. So if I were to do a diet study of this species, the western rat snake in Kansas, here at the museum we have hundreds of these things. So what would be the best way to study the diet? Cut them all open and see what's inside. Even if it's just fur, you can key out the fur and figure out what it was eating. Really, really fascinating stuff, and very similar to that, you can look at reproductive information. So at what age are they reproducing and becoming sexually mature? When they are sexually mature, how many young can they have? So how many eggs do they develop? Things like that. And that is just simply from cutting open voucher specimens like this. You can also look at parasites. This is a really neat thing. We don't have any parasitologists here, but I have worked with outside parasitologists where they borrow a whole bunch of different fluid-preserved mammals. We take out basically their digestive tract from their mouth all the way to their anus, and send them off, and they look them over for parasites, and they identify the parasites. So then you can look at the parasites through time. How are they changing? You can look at the parasites geographically. How do they change from the west to the east? Things like that. There's a whole host of different questions you can try to answer. Also, we have a good variety of specimens for comparative purposes. Whenever I talk about comparative purposes, it's if you were to find, say, a bone, or a paleontologist finds a fossil bone, they can compare to the modern things to try and figure out what species was it closest related to, and things like that. So that's one of the reasons why we have a skeletal collection as well. So not everything's in alcohol, not everything's skinned and stuffed. A lot of things are skeletonized for that reason. Similar to that, ontogeny and development. I know we had one of these programs on ontogeny a few weeks ago as well. Basically, how do things change developmentally through time? And we can also see that when we preserve specimens. So we can preserve eggs, juveniles, and then a series all the way up until mature adults, and see how things are changing. Some of the species change remarkably in that amount of time. Some of them won't change very much at all because the juveniles that come out of the eggs look just like miniature adults. This species right here, the western rat snake, the juveniles look nothing like adults. They look like two completely different species. So when we have series like that, you can then get a better idea of how things change through time and through their development, their ontogeny, if you will. And then one of the last things, and this is kind of obvious, but looking at this right here, you see there's not a whole lot of variation. So most of them look very, very similar. But when we get large series of the same species, we can look at individual variation. And birds is a perfect example of this. You get a good series of birds, you can see a lot of variation, which indicates lots of different things. Sex, basically males can look different from females. Ontogeny again, where the young look different than the adults do. but also the health of the individuals. So if there's certain striking characteristics in a male bird that a female looks for, there's going to be a wide variety of how bright and striking those characters are based on the health of the bird. So is the diet really good? Is the animal heavily parasitized? All of those things will affect the outward appearance of the bird, and therefore the fitness of the bird, which means its ability to reproduce and share its genes from generation to generation. So I hope that makes sense to everybody. So again, I mean, I could talk for hours about all the different reasons why we have collections like this, but this is just kind of a good idea of, you know, kind of a wide variety of why we have collections like this and why we continue to collect. It's very important to continue to collect. Lots of scientists think it's not because we've already got huge series of things. We've got lots of things. But again, you need to think about the time component. If 100 years from now, somebody's looking at things from the early 1900s to, say, the late 2000s, and there's a big period where things are missing in the middle because we stopped collecting, we're missing out on a lot of information there. So we need to continuously collect. We need to collect responsibly and collect for reasons, but we need to continue to collect specimens for those reasons. So I hope you guys learned something today. Again, my name is Curtis Schmidt, the Zoological Collections Manager, and these are the things I love. We'll see you next time.
Thanks for joining us in A New Way to Museum with the Sternberg Museum of Natural History. If you enjoyed this video, like it and subscribe to our channel. Hit the bell for notifications when we release a new video. Support us on Patreon for early access and exclusive content. You can also follow us on all our social media. Links are found in the description. Thanks for watching, and follow your curiosity to new discoveries.